Okay, so in our previous segment, we were talking about angular momentum and rotational things in general. So we've talked about linear things, things that are moving sideways. We've talked about rotating systems. And now we want to talk about a third concept that will be useful in explaining the motions of objects, and that's going to be energy. So energy is going to be abbreviated by the letter E, and it has the units of joules. Now you might be more familiar with calories, but calories is a English unit of energy, whereas the joule is going to be the metric unit for energy. Now, I think that force is more easy to understand because you can feel a force when you pull on something, and you can feel a force when you push on something. But energy is a little bit harder to understand because you can't really feel energy the way that you can feel a force. But energy is going to be defined to be something that you give to a system that's going to cause that system to change in some way. So for example, if you put gasoline into your car, then that's going to give the energy to the engine to make the pistons move, to make the wheels move around. So it's going to change the system when you give it energy. So what are some different types of energy? So first you've got chemical energy. So when a chemical changes its chemical composition, that's going to either release energy or take in energy. We're not so concerned about that because that's chemistry. Okay, the one that's next to it is electrical energy. So you should know that you can get energy from electricity that comes into your house, for example. You also have light energy. Now that's the big one. So we are definitely going to be talking about the energy that light contains. So radio waves have energy. Infrared light has energy. So that's infrared heat. And then also even visible light has energy. Okay, then the one next to that is thermal energy. And so we're not too concerned about that. Again, that's more in chemistry. But the one that's next to it, the mechanical energy, yes, we're definitely going to learn about kinetic energy and potential energy. And then the one next to that's nuclear, and yes, we're going to be doing a lot with nuclear energy, especially nuclear fusion, because that's what gives energy to our sun. So energy, let's talk about mechanical energy, and there are two kinds of mechanical energy: kinetic energy and potential energy. So let's first talk about kinetic energy, energy of motion. So when something is moving, it's got kinetic energy. And there are two kinds of kinetic energy. So you could have the kinetic energy that something has when it's moving sideways, and you've got the kinetic energy that something has when it's rotating. And we're not going to do much with the rotational kinetic energy, but I did want to give you the formula for it. So let's concentrate on the linear kinetic energy. So it's equal to 1/2 m, where m would be the mass of the object, and then v is its speed, but notice it's squared. So it's not just 1/2 mv, it's 1/2 mv squared. That's very important that that velocity is squared. So let's go back to the Queen Mary. So the Queen Mary, the big ship, if it's docked, how much kinetic energy does it have? I hope he said 0, because if it's docked, it's not moving, and if it's not moving, its velocity is 0, and 0 times anything is 0, so it has no kinetic energy. Okay, what about the kinetic energy of a bullet? Well, it shouldn't have too much kinetic energy because a bullet's really small. It doesn't have much mass. How could we give it a lot of kinetic energy? Well, if it's moving fast. So the mass might be small, But if it's moving at 400 feet per second, then that's a lot of speed, and you have to square it, so that could end up being a lot of energy. So just keep in mind that kinetic energy depends on the mass of the object, and it depends on the speed of the object. Another good example of this would be the asteroid that we think killed the dinosaurs. So that asteroid, we think, was about 10 kilometers in diameter. Okay, so that's about the size of the city of Springfield. Okay, and then it was traveling at about, well, let's say about 7 kilometers per second. That means you could go from Minneapolis, Minnesota, down to Springfield, or down to Houston, Texas, in 5 minutes, going at that speed. So it had a tremendous mass, and it had a tremendous amount of speed, so that gives it a really tremendous amount of kinetic energy. So we'll learn more about that later in the course when we talk about asteroids. Okay, I said that we're not really going to do too much with rotational kinetic energy, so let's go on to potential energy. Potential energy is the energy of position, the energy something has because of where it's located at. So for example, here is a thumb drive, and what I'm going to do is put the thumb drive down, and in order to lift the thumb drive up to here, I need to put energy into it. So energy came out of my muscles, such as they are, and I lifted it up to here. So now it's got potential energy. It has the potential to be able to do something. Okay? Now it's not doing anything, right? But it's got the energy. So if I let it go, okay, did you hear that noise? So that was some of the energy coming out of the thumb drive when it hit the table. So that potential energy is stored energy. Okay, the first picture there is a dam, and what that does is it stores the potential energy of water. So what it does is it takes the water that used to be in the river, and then it lifts it up so that it's behind the dam, and so it's stored there as potential energy. And then when you're ready to use that energy, you let it trickle over the dam, and then it turns a turbine, which makes electricity. So potential energy was being turned into electrical energy. Okay, the one that's next to it is a spring, and we're not going to do very much with springs, but I just wanted you to see that if you take a spring and you pull it apart, you just put energy into it. Okay, and on the other hand, if you got a spring and you compress it, you just put energy into it. So that would be stored energy in a spring. The one that's next to that are two molecules, a chemical reaction. So whenever chemical bonds are broken and then chemical bonds are reformed, energy is being used to do that. So that would be chemical energy. Now we're not going to do much with it. And the one that's next to that would be nuclear potential energy. So the energy that's being used to hold the protons and neutrons together in the nucleus. And so we're going to find out that some of that energy can be released in nuclear fission and also in nuclear fusion. Okay, we're going to take a break, and when we come back, we're going to talk about conservation of energy and power.